Alright, so in this video, we're going to be going over arc length with parametric equations. So the first thing I have on the board here is to recall that the arc length of a regular function is L equals the integral from a to b of the square root of 1 plus dy dx squared dx. Now, using what we know about parametric equations, we can actually transform this into something that we can use with parametric to find the arc length. Okay, now using the substitution rule, we know that this integral becomes the integral from alpha to beta. Okay, these are bounds of t, right? This is t equals alpha, t equals beta, whereas this is x equals a and x equals b. Okay, right? So our bounds are kind of equal to a different variable, I guess you could say. Now, when we do our square root, 1 plus, when we did our derivative section, okay, we know that dy dx can be redefined as dy dt over dx dt. And since this is being squared, we can square top and bottom here. Alright, and on the outside we have a dx. Okay, and since we need a dt instead, right, we need a dt because our bounds are equal to t, not x. So we can just divide this by dt and multiply by dt. Okay, and you're like, well, wait, the dt's would immediately cancel out, right? Well, don't think like that, okay? Dx dt is something we can easily find, right? Because dx dt is just the derivative of our x equals equation. Okay, so now we can simplify this and make it look a lot nicer, okay? Don't worry, this isn't our final product. We get the arc length is equal to the integral from alpha to beta of, we find common denominators here, okay? So let me make a bigger radical here. We can just have this be dx dt squared over dx dt squared. So I'll write that down here. Dx dt squared over dx dt squared. Right, that's just one. So we get plus dy dt squared over dx dt squared. And then we have dx dt on the outside times dt. Now, here's what's cool. We can take this dx dt squared out of the radical, okay? We can take that out of the radical and have that be a 1 over dx dt, the square root of dx dt squared plus dy dt squared. And we get a dt on the outside. Oh, and of course our dx dt. But here's the cool part. This dx dt cancels with this 1 over dx dt, right? Which is really, really nice because now the arc length is just this piece, right? So we get the arc length is equal to the integral from alpha to beta of the square root of dx dt squared plus dy dt squared dt. And that is the formula for arc length when dealing with parametric equations. Alright, so let's do a quick example using this formula. Alright, so here we have our example up on the board here. Find the arc length of the unit circle parameterized by x equals cosine t, y equals sine t, and we are on the interval from 0 to 2 pi. Right? So we have our formula up here, and there's two things that we need to find. Right? We need to find dx dt and dy dt, and then we have something that we can put into our integrand and, you know, kind of simplify, I guess. And of course we also need to find our bounds, but that's given to us right in the problem here, 0 to 2 pi. So let's find dx dt. Well, dx dt is just going to be the derivative here, right, which is negative sine t. And dy dt is going to be the derivative of this piece, which is just cosine t. Probably going to get rid of this marker soon. Whatever. Alright, so now, and of course, like I said, our bounds are from 0 to 2 pi. We can plug everything into the integral to get that, or the arc length is the integral from 0 to 2 pi of the square root of negative sine of t. That'll get squared. And then you have plus the cosine of t, and of course that's squared as well. And we have dt. Of course, you see here we have something extremely nice. This is going to be sine squared t plus cosine squared t, so we're actually just going to get 1 here. So this is actually equal to the integral from 0 to 2 pi of dt. Alright, and integrating there, that's a pretty hard one, I guess. We get t evaluated from 0 to 2 pi, and that just ends up being 2 pi, right? So this actually makes a lot of sense, right? This goes with our circumference equation that we know from, well, I don't even know when you would learn that. It's a while ago. Circumference equals 2 pi r, right? And what is the radius of the unit circle? Well, it's 1. So our circumference, our arc length, should be 2 pi, and it is. So that's actually really cool to see, right? You're seeing now with parametric equations, something that you knew already was a thing, like 10 years ago. All right, so yeah, okay, cool. That's gonna do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar in the next video in the series. See you soon.